Hello, everybody. I would like to welcome you all to our virtual symposium towards a true systems approach to reducing food loss and waste from farm to table. I will quickly introduce Dr. Martin Wiedmann. So Dr. Wiedmann is the Gellert Family Professor of Food Safety in the Department of Food Science at Cornell University. His research interests focus on farm-to-table microbial food quality and food safety, and the application of molecular and modeling tools to study biology and transmission of foodborne pathogens and spoilage organisms. Among many roles inside and outside of Cornell University, Dr. Wiedmann also serves as a co-director of the New York State Integrated Food Safety Center of Excellence. Martin, I believe the floor is yours.
Thanks, Al. Just to check whether you can see my slides correctly. Okay. All right, so what I'm going to do is give a quick overview of the symposium and why we're here today, and then really try to set the stage for the following two days. So it's a 2-day symposium, each day about 3.5 to 4 hours. Today we'll probably focus more on technical solutions and technical aspects of addressing food loss and food waste using a systems approach. Tomorrow's agenda will be moderated by Dr. Erin Adalja, and we'll focus more on the social sciences and economics part of the food waste and food loss challenge. So 2 days, each of them about 3.5, 4 hours. I want to thank the Foundation for Food and Agricultural Research, who is a partner in this symposium, who funded a main project that really sponsored and helped develop this session. And then our co-sponsors at Cornell, the Cornell Atkinson Center for Sustainability, the Cornell S.C. Johnson College of Business, specifically the Business of Food Initiative, and the Cornell Institute for Food Systems Industry Partnership Program. And there are a few key people I want to thank, Rajni and Al, who really did heavy lifting on the organization. Sam Lau, who is a graduate research assistant in the Department of Food Science and the Hotel School, and she did a lot of heavy lifting on putting this symposium together. And then all presenters, roundtable participants, the organizers, and the organizer specifically Julie Goddard, who's going to run another roundtable today, and then Erin, who's going to run one of the roundtables tomorrow, in addition to being the moderator for tomorrow. So this symposium is based and really came out of a FAR-funded project, which is development of data-informed approaches to reducing food waste from primary production to consumers, where we use dairy and specifically fluid milk as a model system. So at least today and probably tomorrow, you'll hear a few dairy examples, but we will not just talk about dairy by any stretch. But if it seems maybe a little bit dairy heavy, that is because some of the research work that was done was funded through this project. The big picture goals for today and tomorrow are to discuss the complexities of reducing food waste and loss at a global scale, including possible unintended consequences. And I think that's an important and unique part of our symposium for the next 2 days, because I think we fool ourselves if we think just reducing the amount of food waste that always will have a positive. There are some possible unintended negative consequences that we need to try to foresee and manage on this journey. Another goal is to provide information on technologies and systems approaches. Obviously, this symposium focused on systems approaches that can facilitate food loss and waste reduction, provide insights on the economics of food loss and waste reduction, and encourage and have open discussions. Because the hope is that at least some, if not all, attendees go out of this to make a difference and continue to push the agenda of reducing food loss and waste, and maybe incorporate and use new ideas to move us along on this journey. So here's an outline of what I'm going to talk about as I'm going to sort of set the stage for today. I'm going to start out talking about food loss and food waste, sort of the bigger picture on this, and then going to give some examples of how we can use digital approaches and decision support tools to reduce food waste and loss, using a systems approach, and then end up with sort of a vision for what I call a digital infrastructure that can help us in this effort. So this is one of the statistics that I think many of you, if not all of you, have seen in some permutation or another. This is from the FAO. And FAO, and this is important, differentiates food loss and food waste. With food loss being decrease in quantity and quality of food, resulting from food by food suppliers, but excluding retail, food service, and consumers. So this would be processing and farm. Food waste is what occurs at retail, food service, and consumer levels. Now, I have to warn you that this differentiation of food loss and waste is not always clearly followed. Some people may use these two terms interchangeably. Some may even flip them. And so if someone talks about food loss and waste, you may ask, oh, this is about a clarification. What are you referring to? But this is how FAO approaches it. I'm also sure you've seen various permutations of this graph on the right that just sort of impresses the quantity and the impact of this issue. And here we're focusing just on food loss, so again, that sort of processing and farm level. And the idea is that, somewhere between 10 to a high of 20% of food loss occurs in different countries and in different regions. Now, one thing what you will see here is there's no estimate of the uncertainty or credible intervals around these estimates. We're made to believe that these are very accurate estimates. If you take Western Asia and North Africa, let's say that looks like 11.5%. It's nothing like confident interval error bars, anything that indicates how sure are we about these values. And I think it's one important thing to consider as we go forward on this journey is that to start out, we probably need better ways to measure food loss and waste and start to quantify the uncertainty around these estimates. Because only when we have good measurements tools can we also define whether we're making progress in this journey. Here's another example of some of these estimates, and what you will see here already talks about losses from food supply at retail consumer level. Obviously, FAO would call this food waste, not food losses. Okay, so showing the sort of inconsistency in nomenclature. Again, the numbers here in terms of billions of pounds of foods lost imply an accuracy that I think is definitely not there. 7.1 billion pounds of processed vegetables. I think all of us probably intuitively pretty clear on that. 7.1, yeah, maybe somewhere between 5 and 10, but we don't have the accuracy of 7.1. We need to quantify those uncertainties around these estimates. But I also think these estimates are appropriate and correct in the part that they estimate that it is a substantial issue. It is a substantial issue around the globe. Now, that's the problem. If we go to strategies to reduce food loss and food waste, I just want to provide some examples. This is by no means meant to be a comprehensive summary. You can look at these at the different sectors. You can look at strategies at the farm level, or what we might want to call close to the farm. Obviously, losses in the field, if we look at plant-based foods, can be substantial, particularly in some countries that have a hard time managing pests or drought and other adverse conditions. So improved pest management is a key factor there that could improve, in general, agricultural management could substantially reduce food loss. Better forecasting of needs. It's my understanding that in many areas, particularly on the produce side, you still overplant and overgrow because sometimes it's not clear what the needs are, and that then leads to products being plowed under without ever being used. So better, more accurate tools on forecasting will reduce food waste, food loss at this stage. Improved storage, improved preservation techniques that can be applied early. In many regions, rapid drying is often mentioned as a key need. Improved cooling chain, improved refrigeration, very, very important in many parts of the world as one mechanism to reduce food loss. Processing and retail. some strategy reducing the case size of products, eliminating minimum order rules. So a lot of them are more on the economics business side. Product rotation, inventory rotation, all can help with that. Consumer education, whenever you read about food waste, consumer education is mentioned as a huge need. I think there's a lot of confusion, particularly with regard to date labels. So any label that has a date on it is, what does that mean? Does it mean as soon as it reaches that day, I can eat it the night of March 13th, but if it's the morning of March 14th, overnight, my food went bad and I have to throw it out the next day? Something magical happened over those 8 hours at night? That's not how it works, but there's a lot of confusion about it, and a lot of it leads to food waste. The use of the different types of dates, best by versus use by dates. A lot of work there to be done. And then, part of the pitch and part of the idea of the symposium and my true belief is we need to take it to a systems level. We're not just looking at these individual components, but look at a systems level for reducing food loss and waste, because actions at one part can impact actions further down. For example, if we harvest produce that already is reduced quality for whatever reason, that might be even more likely to lead to loss or waste throughout the system. Recycling, upcycling is a key part of this, but as you often will read, and I agree with, we can look at this as being too late. Let's prevent rather than recycle. I think we've seen this in many parts of society, that prevention being so important. So again, not a comprehensive summary, but give you some idea of the types of strategies that we need to consider and often need to make decisions on. Where do we focus resources? Whether it's as a society, whether it's the government, whether it's as a non-for-profit, or whether it's as a company that functions at various sectors. Where do we put our resources to reduce food waste and loss? Here's another thing taken from the FAO report that talks about the type of interventions toward food loss and waste reduction in advanced economies and developing economies. Ag facility enhancement, cold chain systems. We talked about food loss and waste reduction campaigns, food donation, also very popular, particularly in advanced economies, food waste recycling and various aspects of that. And you can see a lot of investment, a lot of effort in food waste recycling and food donation, but we need to have more in prevention, in my mind. So let's talk a little bit about how we can take more of a systems approach to reducing food waste and food loss. And I'm going to use some ongoing research from our group to illustrate that. And that's really what it's meant to be, an illustration, not this is what someone needs to do or should be doing. So one idea I want to leave people with is that it is the idea of precision food systems. How do we develop better tools to improve our ability to manage food systems in a context that's specific to different environments, different seasons, different consumers, etc. And the tools for precision food systems are being developed in various sectors. Precision agriculture, where we can use GIS and other tools to be much more precise how and when we fertilize, when we grow, when we harvest, use very advanced tools and technologies for this. But then personalized medicine can essentially steal or reuse tools from these two sectors and other sectors to radically improve our ability to reduce food loss and waste and to reduce the environmental impact of food growing, food processing, and food production. In precision food systems, we should have an improved ability to predict and therefore prevent food loss and waste. We can use and should use digital tools to model and predict consumer demands, shelf life, so get away from static dates, but be able to be much more smart about predictions with regard to shelf life and therefore reduce unneeded waste of product that's been thrown away simply because it passes a date that might not accurately reflect its suitability for human consumption. These tools will help us with enhanced upcycling technologies, better use of products, and better food donation programs even. And we will also have can borrow and use improved prevention tools, DNA fingerprinting tools, genomics tools, etc., to better identify sources of organisms, microbes that spoil foods, but also potentially better identify varieties, etc., that might not be as susceptible to spoiling foods. So a lot of technologies that can be borrowed from adjacent disciplines to help in this journey to reducing food loss and food waste. This precision food system obviously needs to go from primary production all the way through finished consumers. If we can integrate this, get better at predicting demands on the consumer side over time in different regions, how they change, that will allow us to reduce food loss and waste throughout the whole system. And tools such as AI, as we have better data availability, can play a huge role in that. Ultimately, one of my visions, our visions of a number of us here at Cornell, is the idea of having digital twins of a whole food system, where we model everything in a food system from primary production to the end, and can even predict what happens if we make certain changes at various levels throughout the food system. Predicted real time versus waiting and do an experiment. Some of these things are not suitable to do experiments. If I make a change in processing or make a change in primary production, it will take me a long time to figure out how that change promulgates through the system and causes changes in the amount of food that is lost or wasted. So one pitch, at least from my side here, is let's work on these digital twins of food systems and use them as digital decision support tools that allow us to make better decisions in terms of what interventions we should use and how we should change our food systems to reduce food loss and food waste. So I'm going to give an example, and this is where one of the fluid milk and the dairy examples comes in, how we can start to build some of these digital twins and digital systems and use them to reduce food loss and food waste. This work was facilitated by the fact that we have a vast amount of data collected over 30 or 40 years on shelf life and food loss and food waste of fluid milk in the state of New York through a program funded by the New York State dairy farmers. And with these data, we developed simulations to predict shelf life to microbial spoilage. And microbial spoilage in fluid milk is one of the major causes of food loss and food waste. You open your milk, it doesn't smell right, it doesn't taste right. Your dates on your fluid milk are typically based on when microbes may start to spoil the milk, that it doesn't have appropriate sensory characteristics anymore. So what we can do is we can develop models, Monte Carlo simulations, to predict microbial populations in fluid milk over time, and then can predict for certain days in shelf life, day 21, day 24, what percent of half gallons or any container size have less than a certain microbial number, what is the distribution of microbial numbers throughout products. So we're not modeling shelf life as one day and one package, but we're really looking at the distribution across different containers. Once we have this base model, we can come up with histograms over time. We can potentially show and even make videos and simulations that show over time. So you can see here, we model over multiple days, what are the microbial populations in this product. So we can use, it's very easy to see that this tool can be used to predict shelf life and say, at a certain point in time, we see too many products showing up here with high bacterial numbers, and therefore we accordingly set the shelf life. Now, once we have developed this base model, we have data to validate, make sure these models actually predict what we see in the real world. And that's really when it gets interesting, because now we can start to explore what-if scenarios. What if we change baseline storage from, let's say, 6 degrees to 4 degrees? And you can see some substantial changes. Rather than 34% of gallons half-gallon containers below a threshold for a very high quality. Now we move to 91%, but just a change in temperature from 6 to 4 degrees centigrade. It's about 5 degrees Fahrenheit difference. Obviously, changes in refrigeration come with costs, come with, greenhouse gas emissions because refrigeration takes energy. But we can predict the impact these changes will have. Does it make sense to further cool milk throughout distribution to 3 or 2 degrees centigrade? Does that provide enough additional extension of shelf life to be worth the cost both to firms, but also to the environment of further enhancing shelf life of these products? We can use other technologies. We can say, what would happen if we use microfiltration, where we try to filter out a proportion of bacteria before we process? And we can run that same short simulation, and in red, you can see what are the improvements that are possible with microfiltration that can allow a firm to make decisions of whether to invest in microfiltration technologies, and compare and contrast it to changes in refrigeration temperatures, or even compare and contrast it to changes on farms where we might use premiums or other structures to encourage farmers to produce higher quality raw milk. So we can compare different interventions for the impact on shelf life. And we can summarize that in some statistics there, et cetera, and really help with decision making. Now, once we have these tools, we can take it further. I mean, as I mentioned before, and as most of us are very aware of, one of the challenges in waste are these dates, the best by dates. The US population is probably split half, whether it's okay to drink milk past the best by date or not, or to throw it out. What that also means is, even at the retail shelf, if you move to a retail shelf and you see some milk with a date of 9/17, some with a date of 9/5, you will tend to pick the 9/17, which means at some point this milk has moved past its best by date, can't be sold, and will become food waste. One way to counteract this in the good old days was to simply mark down. Now, this is the 21st century. We have worker shortages. It's not really that feasible anymore to do markdown in the good old-fashioned way. But once we have the models that we have described, and we're actually running a trial for this right now at Cornell, we can completely replace shelf life labels. Now have a QR code as well as a temperature sensor potentially, and use those to predict shelf life, but then also tie this into dynamic pricing, where as product moves closer to the end of shelf life, we reduce the price, therefore moving product out before it is wasted and has to be discarded. So we can use the same technology, the same digital twins, to also do better prediction and better supply chain management. Once we start technologies like this, it's not a far step removed from then envisioning the next step, where it would be a smart refrigerator that actually knows the shelf life of the products in your kitchen and will tell you when you come home Monday night, these are the products that are close to end of shelf life, and here's a suggested recipe of how you can utilize all the products that are close to the end of shelf life to reduce food waste. So it's a whole new infrastructure that can reduce food waste with some of these tools. So we've done some of this work on the dairy side. We're also doing similar work with support by the Walmart Foundation for the produce supply chain. So this is not just a dairy approach. It's an approach that is very applicable to a lot of highly perishable products, where going past the best by date is a major reason for food waste. So one other example to round this up is when we look at some more rare spoilage events, such as yogurt spoilage with mold. Same thing, we can do predictions and use these predictions to help companies to decide different technologies to use to reduce food waste and spoilage of yogurt. So these tools are applicable to a wide variety of products. It does not end there in terms of building digital twins. We can do sophisticated models of processing plants, where we model transmission of microbes in the environment. and model the supply chain. Here you see what's called an agent-based model. And when you look at it, you can see that this is a food processing operation. It has two lines here with various connections. And you can model what's happening in this processing facility over time. Blue indicates water, people moving in and out, sanitation happening, how can microbes be transmitted, and you can use that to reduce microbial transmission onto product and therefore reducing food spoilage due to microbes that can cause food spoilage. So tremendous amount of tools that once you tie them all together, you really get close to these digital twins that I mentioned. You can take this to the field. This is actually not yet a food spoilage examples, but these are models that we developed that predict food safety issues, where you have different fields, you have spatial context, you have a stream here, you have roads here, you have locations of farms, and you can predict, given enough data, where you're more likely to have pathogens, but also potentially where you're more likely to have spoilage organisms or reduced product yields, etc. So if you add these on-farm GIS models, Monte Carlo simulations, agent-based models for processing facilities, you can see how this can tie together for a farm-to-table digital twin of a food system that can be used to optimize, food production and reduce food loss and waste. But in addition, can reduce food safety issues also. You can feed these models with machine learning tools that predict quality management practices that increase the risk of contaminating milk, etc. And you build this whole system that I mentioned. So, and this is where we then hopefully will end up. We have a comprehensive system from farm, processor, retail to consumer. We monitor impacts, we validate, communicate the impacts, we set mitigation targets, we define regulate standards, we incentivize sustainable consumption, and tie all of this together. And that sort of outlines, hopefully, the sort of idea of a digital infrastructure and a digital food system that can reduce food loss and food waste. So I'm going to talk a little bit more about what that would look like. We talked about these digital twins. We then can globally, US-wide or worldwide, at processing facility locations. We can also minimize distance for transportation, another potential contributor, not necessarily to food loss and waste, but to the the environmental impact of food production and distribution. So we can make this a large optimization problem that can reduce overall environmental impact of food production and processing and distribution. However, one challenge that we've started working on through another project that is funded by the NSF Artificial Intelligence for Food Systems program is, how do we get enough data to feed these models to really allow us to make accurate predictions? Data sharing is essential, but in the food industry, there are many barriers to data sharing, not just in the food industry in general. But food industry is, for example, in many cases behind on having data even available in digital form. They're often non-digital. They often do not use standard data schema. There's a substantial fear of misuse of data, of legal liabilities, reputational damage. If someone has data that shows how likely my product is to spoil, or lo and behold, even has data that might indicate that there is a risk of a food safety issue. Mandatory data sharing is not really an easy solution, because one reaction to mandatory data sharing could be to simply create less data so you can't share the data. So the business model around data sharing is not well developed. There's some work to be done there. And we see this even in precision agriculture and in other areas. So we need to develop more sophisticated data sharing approaches to make this work. these data sharing approaches need to assure privacy and confidentiality. Again, and you see a theme here, there are other areas where we can borrow approaches to achieve this. And one area would be if you think about census data in the US that are collected and are used to make prediction and are shared, but we want to protect the privacy of the individual. For these applications, different approaches have been developed to assure privacy and confidentiality. There are methods called differential privacy, where you can add noise to the data so that you can guarantee a user's plausible deniability. The amount of data you can add can depend on the sensitivity of the data. The challenge with this, and it's pretty obvious, right? If I add noise, my accuracy goes down, so the utility of the data goes down. So I need to have large amounts of data for this to work. The approach is called federated learning, where the data, the input data are actually on the cloud, they're more privately held, and it's the models that use the data to update the parameter, but they don't use the actual data. So you actually don't share the data, but the data still can be used to improve models and update models. And combination of these methods. Again, this is not my area of expertise, but my pitch here is that we need to include this as we develop these sophisticated digital food systems to manage food waste and food loss and reduce food waste and loss, to think about data sharing approaches. So in summary, I hope I've sort of given you, not that most of you haven't had it before, that idea that a food systems approach to reducing food loss and waste is essential. But it still often is missing. And I've read a few things this week about why we need to just do more on farm to reduce food waste. And while I appreciate the idea, I think my message always is we need to do more throughout and link the effort throughout the whole system rather than just focusing on one component of it. Whether it's consumer education on one end or farm on the other end, it needs to be a food systems approach. While upcycling and recycling are a part of the picture, an important part of the picture, and I don't want to minimize their importance, prevention is essential. Prevention of food loss and food waste, and needs to occur across the food chain. Many of the tools needed are available, but they're not being used as much as they can yet. Implementation of these tools and development of an infrastructure is needed. And I at least believe it's time to think about a digital food infrastructure to help us address some of these challenges. Now, when we work on reducing food loss and food waste, and this will be covered more tomorrow, we also need to consider trade-offs. Not every strategy that reduces food waste will be a net positive for the world. We can refrigerate or freeze all the food, and that will reduce potentially food loss and food waste and food spoilage, but the energy needs are substantial, and we might have some overall net negative effects. So we need to really consider the big picture. And again, that's where these digital twins could be very, very valuable, particularly if they're combined, as they need to be, with better data collection systems to really allow us to collect data along the food chain. So I want to thank my group, our group, past and current collaborators that contribute to this, and the financial support from a number of different groups that provided us with the brain power and the financial power to develop some of these initial tools and things that I was able to share today. So that's what I had. What I want to do is maybe open it up quickly for a few questions before we move to the first round table. Okay. Any questions? Okay, I see one. So one question from Gabriel is there any example of how the digital twins could work when testing interventions regarding household food waste? Well, so one of them would be and I'm really trying to sort of brainstorming here, and this could also be a good question for the panel, would be to, for example, look at differences in labeling strategies, or even looking at what if we can improve training, if we get 5% of people to not take best by dates as a given, but use some food after the best buy dates? What would that total impact of it be? And then we combine it with different labels, combine it with extended labels, etc. So you could come up with some ideas. It's probably, I would think it's not necessarily initially the biggest strengths of it is on the consumer side. But I think when you also combine it with economic incentives, for example, to understand, and the picture is going to get complex to understand if you have dynamic pricing, for example, you have a reduced price of product closer to the end of shelf life. Now, for some people, they will assume that that food is of lower quality. They might not purchase it. So there's what I would call negative feedback loops. We can incorporate them into some of these digital twins. Okay, other questions? Okay, and happy to, for anyone, if questions come up, to add them as we have our first round table.